Starting off with number 9, it says simplify. The final answer may or may not be in factored form. We'll get to that once we get to the answer. But in order to subtract two different fractions, you need a common denominator, you need a LCD. And in order to do that, you want to factor first. So this first denominator, I could pull out what? What's the GCF of 6 and 14? 2. What's left over on the inside? 3x minus 7. Okay, so that is the first denominator in factored form. What about the second denominator over here? I could pull out a 3 and an x. That's right, the GCF is 3x. And what's left over in there? 3x minus 7 again. All right, great. So now that I know both factored form denominators, I could conclude that my LCD is, that's exactly right, the binomial that repeats, that matches up, 3x minus 7. And also what else?
3x, 2.
The 3x and the 2. And this is all being multiplied together. Okay? If you wanted to, you could already multiply the 3 and the 2 and write it as a 6 if you want, okay? But the bottom line is once you have this LCD, you're going to change both fractions to become that LCD. So my LCD is going to be I'll just leave it as a 2 times 3x times 3x minus 7. And when I look at my first factored form denominator, what's missing to change it to this LCD? I have a 2, I have a 2. I have the binomial 3x minus 7, 3x minus 7. What's missing? The 3x. So I need to multiply both top and bottom by 3x by 3x. So up here I will get a 3x. Are you with me? I hope so. The second denominator that's in factored form, I need to change it also to have a 2 times 3x times 3x minus 7. So what's missing from here to make it look like this? A 2, right? Bless you. So yeah, we're going to have to multiply both top and bottom by 2. So up here we have a 2x. So at this point, we now have a common denominator and we are now able to combine the top with the top. So I really have a 3x that is a minus sign with the 2x. So that's a simple 1x, right? So your answer is x over the common denominator, the LCD, 2 times 3. But I might as well do 2 times 3 and write it as 6x times the binomial 3x minus 7. So this is the answer right here. 6. No, wait, that's not the answer. You know why? Because you could cancel the x. This x up here cancels with that x down there. So that would leave us with a 1 over 6 3x minus 7. Because if there's nothing left up on top, you have to put the 1 up there. Now if there's nothing left on the bottom, you could put the 1 on the bottom, but anything over 1 is the same thing, so it's not necessary. But if everything cancels out up on top, you have to put a 1. And on the instructions it says it may or may not be in factored form. In other words, this is factored form. Maybe your answer is going to be 1 over 18x minus 42. Maybe they actually distributed, they didn't leave it in factored form. So we're looking for this or we're looking for that on our multiple choice answers. And okay, sorry about that. When we look for 1 over 6 times 3x minus 7, it's not there. There's a 6 times 3x minus 7, but that's not a 1. So it's none of these in this case. Right here on number 10, they're asking us to subtract two fractions. And of course, we need to get an LCD. And let's read the instructions. After getting the LCD and doing the math, type in only the numerator of your final answer without spaces between the terms. Example, 3x minus 7, right? So they want us to get this answer, but obviously it's hard to type in a fraction, so they just want you to type in only the numerator of your final answer. So let me work through this. in order to subtract two fractions, you need to get an LCD. And in order to do that, you want to factor the denominators. So that first fraction, when I factor it, it's going to become y, and you think what times what is negative 12, that if you add together is a b value negative 1, that'll be a negative 4 and a positive 3. And the second fraction, also quadratic trinomial with the a value of 1, you could put the y, and think what times what is 6, that if you combine together is the middle value 5. Again, what times what is c, that if you combine together is b, that'll be a positive 3 times a positive 2. Now, to write my LCD, you take what repeats in both, which in this case, the y plus 3 matches up with the y plus 3. So you just write that down one time, y plus 3. And that is, of course, what repeated in both. And what about everything else? You just bring down the rest. So you also have the y, sorry, give me a second. You have the y minus 4 from right here. And you also have the y plus 2. I'm also going to write that down, y plus 2. So this is the LCD. And I would probably write it in order, y plus 2, then y plus 3, then y minus 4. But the bottom line is you're going to have to change both of these factored form denominators to look like this. So the first fraction, you're going to have the LCD y plus 2, y plus 3, y minus 4. And you got to ask yourself, how do you change the first denominator to become this LCD? Well, you have the y minus 4, that's good. You have the y plus 3, that's good. But you're missing the y plus 2. So obviously to change this to this, you got to multiply by y plus 2. So you're going to multiply both top and bottom by y plus 2. Multiply both top and bottom by y plus 2. And you are going to distribute 3 times y, that's 3y. 3 times 2, that's 6. And on the other one, we also want that LCD down here, so we have the y plus 2 times y plus 3 times y minus 4. And we ask ourselves, how do I change this to become this? Well, you have the y plus 3, there it is. You have the y plus 2, there it is, but it's missing the y minus 4. So I need to multiply both top and bottom by y minus 4. Y minus 4. And of course, 2 times y is 2y, and 2 times negative 4 is negative 8. So now that I have two fractions with the LCD, with the lowest common denominator in both fractions, I will be able to subtract them and get an answer that will be over that LCD of y plus 2, y plus 3, and y minus 4. Okay, now here's the tricky part. We are subtracting. So that minus sign needs to get distributed to both the 2y and the 8. So that's going to become a negative 2y. It's going to become a positive 8. And now you are able to combine the y's with the y's. I have a 3y with a negative 2y. That'll give me one single y. Keep in mind that minus is already gone because I already distributed it. And then I could combine the plus 6 with the plus 8, giving me a plus 14. And ladies and gentlemen, we are done, unless we have a y plus 14 down here that I could cancel with that y plus 14, but we are done. Wow. But what did the instructions say? Once again, only type in the numerator of your answer, because you can't really type in the whole thing. It'd be too complicated. So all you got to do is type in y plus 14. Okay? So that's what you're going to type in to get an answer. Y plus 14. Okay? And it looks like I don't have an alternative of 1. I want to try to change that, but don't put a 1. Just put y. Even though there is technically a 1 in front of the y, just put a y. No, don't put a 1. So that's what you need to type in to get full credit on that question. So not all questions on the quiz are going to be actually asking you to find the final answer on this one. It just says, what's the LCD of this problem? Okay, so to find the LCD, you know you need to factor both denominators first. Okay, So that first denominator factors down to what? Anybody? We have a negative 12 as a C value. We need a negative 1 as a B value. Negative 4, positive 3. That's exactly right. And let's factor the second denominator. We have y's right there. Y. What times what is negative 6 that if you combine together is positive 1? Plus 2. Negative 2. Positive 3, right? Negative 2, positive 3. Okay, now that we have both denominators factored, we could look at both denominators and see what matches up. As you can see, there's a y plus 3 there and a y plus 3 there, which means that our LCD will be that first binomial y plus 3. Okay, and then what about the rest? You have to bring it down. So you also have the y minus 4 left over and also the y minus 2. You bring all that down and all three binomials multiplied together will be your LCD. And that's all they're asking for. They're not actually asking you to subtract the fractions. They're just asking you what is the LCD of this question, and that is your answer. When you look for it on the multiple choice, remember it could be in any order. It could be y minus 2 first, then y plus 3, then y minus 4, or it could be in this order right here. So I hope we understand that question. Let's move on to the next one. This one looks a little more fun, right? So we have a complex number. The numerator is an actual subtraction problem of two fractions. The denominator is a fraction. This is a complex rational expression. So let's begin by working on the top first. Let's ignore the bottom. So what if we had this subtraction problem of these two fractions? I would need a common denominator to be able to subtract those two fractions. What would the common denominator be of those two fractions? X times x minus 4, right? You have this denominator x, you have this denominator x minus 4. So I'm going to rewrite this subtraction problem of two fractions, but the common denominator will be both of those multiplied together. But I'm not actually going to multiply them, I'm just going to write it as x times x minus 4. Now, this first denominator, what must I do to make it look like this common denominator x times x minus 4? What's missing? The x minus 4. So I'm going to multiply both top and bottom by x minus 4. Multiply both top and bottom by x minus 4. This is the first time we get to this type of question where we have to multiply a binomial with a binomial. So we're going to have to distribute x times x squared, x times 3, positive 3x, negative 4 times x, negative 4x, negative 4 times 3, negative 12. And when you combine the two middle terms, you're going to get x squared minus 1x or minus x minus 12. And that is the numerator of that first fraction on the top of this complex rational expression. Now, the other one, I have an x minus 4, but I need it to be an x minus 4 times x. So it's obviously missing the multiplication of x. You have the x minus 4, but you need the times x. So multiply the top by x, and you'll get a 2x up here. And now that I have a LCD, a common denominator on both fractions, now I could actually worry about taking this numerator and subtracting 2x from it. So that's really just understanding that the negative sign belongs to the 2, so that's like a negative 2x, and you need to combine it with this other x. And of course the answer will be over that common denominator x times x minus 4. Okay, so what is our answer? We have the x squared, we have the negative 1x minus 2x, that'll be a negative 3x, and then finally the minus 12. So that's a quadratic trinomial. You should try and factor it, maybe, I'm not sure if this could actually happen, but maybe up on top you could factor further and think what times what is negative 12, that if you combine together is negative 3, negative 1 times 12, negative 2 times 6, negative 4 times 3, nope, it doesn't work, so scratch that. So this right here is barely the numerator of our complex rational expression. That was the answer to this top part. So I'm going to put maybe the word top right here, or numerator. That way I know I'm going to write that on top over this guy down here, which is x minus 3 over x squared minus 4x. So let me rewrite this. Okay, so I rewrote it the top one is right here, and then we have this huge division bar, which I am writing as a division sign, and then the bottom fraction is right there. So I'm going to change this division to multiplication and flip the second fraction only. So the division is going to become multiplication. The second fraction, you're going to have the x minus 3 on the bottom instead of the top. What just happened? And the x squared minus 4x, I could pull out an x from that binomial. So if I do pull out an x as I move it up, I will have an x minus 4 left over on the inside. So the first fraction is just going to come down. And it's over x times x minus 4. Then we could cancel out whatever we can. There's an x minus 4 and an x minus 4. There's also this x down here with that x up there. And that should be our answer, x squared minus 3x minus 12 over x minus 3. You're supposed to try and factor this, but it's not factorable. So this would be our answer. So on this question, you want to get a common denominator, an LCD. And if we look at the denominators, first of all, they're monomials. You're supposed to factor them, but you can't really, the only thing you could do is rewrite the h squared as h times h. So what we really have is a 4, a g, an h, and we have a 4, an h, and an h. So what is it that pairs up in both to write our LCD? There is a 4, and there's also an h. So I'm going to write down 4h, and then the rest I need to bring down. The g I need to bring down, and also this other extra h I need to bring down. So when I multiply these guys together, 4 times h times g, that'll be a 4h squared g as a common denominator. Or you could just leave it like that for now. The 4hg, 4hg. And ask yourself, what do you do to this 4gh to get 2 h's right there? Well, you got to multiply both top and bottom by an extra h, giving you a 7h. And then what do you do to this 4hh to get a 4hhg? Well, you have to multiply by a g, both top and bottom. So you get a 3g up there. So your final answer will be the 7h plus 3g over the common denominator 4hh. So you might as well change it back to h squared with a g. So that's your final answer to that one. And if we look at the multiple choice answers, none of those are there. This one looks like it, but it doesn't have a h squared. That one doesn't have a g either. So yeah, none of these would be the correct answer on this one. Number 14. This one could be very challenging or it could be very easy. All right, depending on what path you take. So on this one, I have a fraction minus a number, and if you wanted to, you could put that or that single term over a 1, and then worry about getting a common denominator, and then worry about adding and subtracting the numerators, right? But before beginning that, it might be a better idea to look at this numerator, actually look at the whole thing, and could you factor anything? And yes, you could factor from the numerator. You could factor what out of the numerator? A 3. And we are going to have an x plus 7 left over. So maybe I should rewrite this to make it a little clearer. 3 times x plus 7 over x plus 7 minus 6x. So instead of getting a common denominator and adding the fractions, why not factor and then recognize that you have the same x plus 7 up on top and not on the bottom, which cancels out. So what you really have here is 3 minus 6x. And we're looking for that as an answer, and maybe it's none of these, right? But let's look at the answers. on this answer, I mean, if I'm looking at this, obviously this is in factored form, so let me factor out a 3, and I will have a 1 minus 2x left over. And even to make it look nicer, you could have the 3 with the negative 2x plus 1. And if you really wanted to, you could make it even look nicer by factoring out a negative 1 in addition to the 3. So instead of a 3, having a negative 3 out here, then having a 2x minus 1 on the inside. So even though none of these show up, I'm actually going to change it so it will appear. This answer right here will appear on your practice test, negative 3. So I messed up on the answers right here. This is the answer that you're going to have to select on the practice test. And last but not least, we have this easy question. Because there's no addition or subtraction, it's a division of two fractions, which means all we're going to do is change the division to multiplication, flip the second fraction, and then we'll be good to go. So that second fraction is going to be a 4x to the third y over x y to the seventh. The first fraction, I actually need to do a little bit of work. The second power on 3 to the second power is 9. And then when you put the second power on the x, that'll be x to the second. And a power to a power you multiply, so that'll be y to the sixth. And then at the bottom we have the 36x. And now that we have pure multiplication everywhere, no addition or subtraction anywhere, we could start canceling things out. So let's cancel the 9 with the 36, giving us a 4. And then we could even further cancel this 4 down here with that 4 up there. And in addition to that, we could cancel the x squared, no, the x down here with one of the x's on the x squared. And we could also cancel the y to the sixth up here with 6 of these y's down here, leaving you 1 y down there. And then we could cancel this y up here with that 1 y down there. Those disappear as well. And we could also cancel this x left over up here with that x left over down there. That disappears as well. So what's the only thing left? X to the third power. And that is your answer, x to the third power.